Today's video is about electricity. This video is going to be just the introduction. We'll get into the calculations a little bit later. So I got to pull up the other half of the PowerPoint here. Okay. So a big part of the introduction we're not going to spend a lot of time on, but essentially electricity is electrons moving. So your PowerPoint goes through a lot about elements and atoms and the structure of an atom. Hopefully this is review, but this is not really the focus of what we're going to be doing. But all you really need to know is that when we talk about electricity, it's the electrons on the outside of the nucleus that are moving around. So I'm going to skip a lot of this, and we're going to go way past all of this. The first part of this is telling you how we figure out how many electrons that a atom will share. They're called valence electrons. And conductors have electrons that are able to be exchanged or flow between atoms, and insulators don't really exchange electrons. And it has to do with their valence electrons. Metals are examples, usually examples of good conductors. They usually have electrons that are easily shared. And so we often use a metal for our electrical wires because they conduct electricity. So if you look at this pair of pliers, the metal part is a good conductor, and then we usually put some kind of a rubber coating on it to make it an insulator, so that in case you do ever touch anything electrical, it's not going to shock you because it's not going to go through that rubber insulator. Okay, so now we get to the important stuff. We're going to be learning about three properties of electricity: voltage, current, and resistance. We measure voltage with volts, which is signified with a V. Current is measured in amperes or amps, and that's signified with an A. And resistance is measured in ohms, which is signified with this upside down horseshoe thingy. So when we talk about electricity, we can make an analogy with water. Electrons flowing is a lot like water flowing. If we want to measure the amperes or the current, we'd be measuring how fast the water would be flowing. So right now our switch or our faucet is turned off. But if so the question is, when the faucet is off, is there any flow? There is no flow of water, and just like an electrical circuit, if the light switch is off, there's no flow of electrical current. But if you turn the switch on, the faucet or our electrical switch, now the current starts to flow, and that is also true with electricity. So here's our little circuit. We switch it on, and our current flows, and then that lights up our light bulb. So when we write a current in science, the correct way to do it is to show electrons moving from the negative, because that's where electrons are, is in the negative, to the positive. For some reason a long time ago, that when they first started to measure it, they thought it was the opposite way, and then so that's the conventional way that engineers still use to this day, even though it's not right. I really don't care. Project Lead the Way is going to use the conventional method because it's an engineering class, but in real life the electrons flow from the negative to the positive. Again, that's not really an important point, so I don't really care. So now when we talk about voltage, voltage is basically the amount of pressure. So the more water we have piled up in this tank, the more pressure we're going to have. So when the faucet is switched off, is there any pressure? There certainly is pressure. So the voltage is there whether the faucet is turned on or not. And then when we turn the faucet or our switch on, is there still pressure? Yeah, there is. So it will continue to flow until the pressure is gone, until our voltage has dropped. And if you measure voltage in batteries, you'll notice that once the voltage gets low enough, then batteries stop working. So here's our little circuit. There is voltage in this battery, so we turn it on. That allows the current to flow. So now when we talk about resistance, resistance is measured in ohms, and if there was a rock or a pebble or something that got in this pipe, and so drop a rock in, gets sucked into the pipe, that's going to reduce the amount of water that's able to go through our faucet. So our flow is decreased. And the same thing happens in circuits. If we insert something called a resistor, and a resistor is a lot like the rock that got in the faucet, the resistor is going to reduce the flow of electrons. And it doesn't matter where the resistor is in our circuit, but it's going to reduce the flow of electrons, and then we'll notice if we're using a light bulb, it'll get dimmer, or if we're using a motor, the motor will decrease in speed. So resistors reduce the flow of electrons, which can be useful, and so therefore we can use resistors to control the amount of electricity that we have. So that's going to be the end of this video. In the next video we'll talk about measuring voltage, amperes, and resistance, and then also how do we calculate this using our equation for electricity.